Welcome to the Computer World Terminologies and Concepts series. Today we're exploring server and client and understanding client-server architecture. This is a fundamental model that powers nearly every web application, email service, and online platform you use daily. In this video, we'll break down how clients and servers communicate with each other, what roles they play, and why this architecture is so important in modern computing. At the heart of client-server architecture is the request-response cycle. It works like this. A client, which is typically your browser or an application on your device, makes an HTTP request to a server. The server, a powerful computer sitting somewhere in a data center, receives that request, processes it, and sends back a response. The client then receives and displays that response to you. This back-and-forth communication is the fundamental basis of how all web applications work. The client always initiates the conversation by sending a request first. Let's dive deeper into what actually happens when you browse the web. Step 1, you type a URL into your browser. Step 2, your browser performs a domain name system, or DNS resolution, converting the domain name into an IP address so it knows where to find the server. Step 3, a TCP connection is established between your computer and the server using the three-way handshake. Step 4, your browser sends the HTTP request with your method, URL, headers, and body. Step 5, the server receives this request, validates it, executes the necessary operations, and queries databases if needed. Step 6, the server sends back an HTTP response with a status code, headers, and content. Step 7, your browser receives this response and renders the HTML, applies CSS styling, and executes any JavaScript code to display the final web page to you. Client-server architecture has several key characteristics that make it so effective. First, it provides centralized security. All authentication, authorization, and data encryption happen on the server side using HTTPS and TLS protocols. The server also acts as a firewall, protecting your data. Second, it offers excellent scalability. If you need to handle more users, you can add more servers and use load balancing to distribute requests across them. Third, it follows the separation of concerns principle. Business logic and data processing happen on the server, while the user interface lives on the client. This keeps things organized and maintainable. Finally, it improves efficiency. The server handles heavy lifting, reducing the processing burden on your device, while caching and bandwidth optimization make everything faster. Like any architecture, client-server has both strengths and weaknesses. The main advantages are centralized security with full access control, the ability to scale horizontally by adding more servers, easy management and maintenance of the entire system, efficient backup and disaster recovery procedures, and better resource optimization since the server handles most of the heavy work. However, there are disadvantages to consider. If the server experiences high load, network traffic can become congested. Server hardware is expensive to purchase and maintain. The server becomes a single point of failure, meaning if it goes down, clients can't access the service. Additionally, if network connectivity is lost, users can't access data stored on the server. Finally, the centralized server becomes an attractive target for cyberattacks, making security a constant concern. Client-server architecture powers countless real-world applications that you use every day. Web browsing through Chrome, Firefox, and Safari all work using this model. Email services like Gmail, Outlook, and Yahoo Mail are built on client-server architecture. Online banking apps and web portals use this architecture to securely handle your financial transactions. Cloud storage services like Google Drive, Dropbox, and OneDrive use it to upload and synchronize your files. E-commerce platforms like Amazon, eBay, and Shopify rely on this architecture for shopping carts and payment processing. Multiplayer games like Fortnite and League of Legends use it to synchronize gameplay across players. Social media platforms use it for feed updates, messaging, and photo storage. Even healthcare systems use client-server architecture for electronic health records and telemedicine services. Despite its advantages, client-server architecture faces several challenges. The single point of failure problem means if the server goes down, the entire system becomes inaccessible. The solution is to set up redundancy with backup servers. Performance bottlenecks occur when the server receives too many requests simultaneously. Load balancing and caching can help distribute the workload. High infrastructure costs are required for expensive server hardware and ongoing maintenance. Cloud hosting and resource optimization can reduce these expenses. Network dependency means there's no offline access to server-stored data. Some applications implement offline-first design or local caching to address this. The server becomes a security target that attracts cyberattacks. Solutions include firewalls and DDoS protection systems. Finally, the complexity of setup and management requires specialized knowledge. DevOps practices and automation tools help simplify these operations. Client-server architecture isn't going away, but it's definitely evolving. Cloud computing is decentralizing servers across global data centers, making systems more flexible and cost-effective. Edge computing brings servers closer to users, reducing latency and enabling real-time processing. Artificial intelligence and machine learning are adding intelligent capabilities with specialized hardware. Containerization using Docker and Kubernetes improves scalability and deployment flexibility. Fifth-generation, or 5G networks, provide ultra-fast, low-latency connectivity that enhances performance across all systems. Hybrid architectures combine on-premises and cloud solutions to get the best of both worlds. The fundamental principles of client-server remain relevant and continue to adapt to modern computing challenges and opportunities. Understanding this architecture gives you the foundation for learning about web development, system design, and modern software engineering.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.